October 14, 2024, a rocket launches from Kennedy Space Center in Florida. On board, NASA's most expensive, most ambitious spacecraft ever built for a planetary mission. A 5.5-year journey, 1.8 billion miles through deep space. Its destination? A tiny, frozen moon orbiting the largest planet in our solar system. Its mission? To answer the single most important question in the history of science. Are we alone? This is Europa. And what scientists have recently discovered here, using the most powerful telescope ever built, has completely changed what we thought we knew about life in the universe. Today, we're going to go through all of it, step by step, discovery by discovery, because what's happening right now, in real time, is genuinely one of the most extraordinary moments in human history. First, let's understand what we're dealing with. Europa is one of Jupiter's 95 moons. It's slightly smaller than our own moon, and from the outside, it looks completely lifeless, a smooth, cracked ball of ice, drifting silently in the frozen darkness more than 600 million kilometers from the sun. But that surface? It's hiding something. Beneath Europa's icy crust, which is estimated to be between 15 and 25 kilometers thick, scientists believe there is a liquid saltwater ocean. Not a small pond, not a puddle. A global ocean, one that could be up to 100 kilometers deep. And here's the number that will blow your mind. That ocean may contain more than twice the volume of all of Earth's oceans combined. All of them, together, doubled, inside a moon smaller than ours. Now the obvious question, how is any water liquid out there? Jupiter is so far from the sun that temperatures on Europa's surface drop to around -160 degrees Celsius. The answer is something called tidal heating. Jupiter is the biggest planet in our solar system, so massive that its gravitational pull constantly squeezes and stretches Europa as it orbits. Like squeezing a stress ball over and over again, that constant flexing creates friction inside Europa, and that friction generates heat. Enough heat to keep an ocean liquid, deep below the ice, for possibly billions of years. Billions of years. That's longer than complex life has existed on Earth. Now here's where things get genuinely exciting. In September 2023, two independent teams of scientists pointed the James Webb Space Telescope, the most powerful telescope ever built, at Europa. And what they found sent shockwaves through the scientific community. They detected carbon dioxide on Europa's surface. Carbon, the fundamental building block of all life as we know it on Earth. Now, CO2 by itself isn't shocking. What shocked scientists was where it came from. The carbon dioxide was concentrated in a specific region called Terra Regio, a geologically young area of Europa where the icy surface has been recently disrupted and reshuffled. Scientists call this chaos terrain. And chaos terrain is significant because it's where the surface ice and the underground ocean exchange material. In other words, that carbon didn't come from a meteor impact. It didn't come from space. It came from inside Europa, from the ocean below. As NASA scientist Geronimo Villanueva put it, on Earth, life likes chemical diversity. The more diversity, the better. We're carbon-based life. Understanding the chemistry of Europa's ocean will help us determine whether it's hostile to life, or whether it might be a good place for life. So let's count what we now know Europa's ocean has. Liquid water, salt, carbon, a rocky seafloor. That's the recipe, right there. Water, chemistry, energy, and time. Those are the four conditions scientists say are necessary for life. And Europa appears to check every single box. But there's one more piece to this puzzle, and it might be the most important one. In June 2024, a peer-reviewed study published in the journal JGR Planets found that hydrothermal vents could exist on the seafloor of Europa's ocean and could survive under a wide range of conditions for millions to billions of years. Now, why does this matter so much? Let me take you somewhere on Earth first. Go to the deepest part of our own ocean, somewhere so deep that not a single ray of sunlight has ever penetrated. No photosynthesis, no warmth, completely dark, crushing pressure. It should be completely dead. And yet, when scientists first explored the hydrothermal vents at the bottom of Earth's ocean, they found explosions of life. Entire ecosystems, bacteria, tube worms, crabs, fish, all thriving around superheated water venting from the ocean floor. No sunlight needed, just heat, water, and chemistry. This discovery completely changed our understanding of where life can exist. And now, scientists believe Europa may have almost identical conditions. Low-temperature hydrothermal vents on Europa's seafloor, providing chemical energy, providing heat, providing the exact same kind of environment where life first emerged on Earth. As the lead author of the 2024 study stated, low-temperature hydrothermal systems could have been sustained on ocean worlds beyond Earth over timescales comparable to that required for life to take hold on Earth. Let that sink in. The same timescales, the same conditions, on a moon of Jupiter. And this is exactly why NASA launched Europa Clipper on October 14, 2024. It's the largest spacecraft NASA has ever built for a planetary science mission. Solar panels stretching over 30 meters wide, 9 scientific instruments on board, a titanium radiation vault protecting its electronics from Jupiter's deadly magnetic field. The mission cost $5.2 billion, and every single penny is targeted at one question: is Europa habitable? Here's the plan. Europa Clipper will use a gravity assist from Mars in 2025 and Earth in 2026 to gain speed. It will arrive at Jupiter in April 2030. Then it will orbit Jupiter and perform 49 close flybys of Europa, getting as close as just 25 kilometers above the surface. The instruments on board will use radar to penetrate the ice shell and measure the ocean depth, analyze Europa's thin atmosphere for signs of ocean chemistry, map the surface in detail, looking for chaos terrain, plumes, and fresh ocean material, search for organic molecules, and critically, Europa Clipper is designed to select the landing site for a future Europa lander mission. A mission that would actually drill through the ice and sample the ocean directly. NASA Administrator Bill Nelson said at the launch, "By exploring the unknown, Europa Clipper will help us better understand whether there is the potential for life not just within our solar system, but among the billions of moons and planets beyond our sun." Think about that, not just Europa, but billions of moons and planets. Because if life can exist in Europa's dark, frozen, sunless ocean, it could exist almost anywhere. Now let's ask the question nobody wants to say out loud. What if Europa Clipper gets there in 2030 and finds it? What if the radar detects something moving beneath the ice? What if the mass spectrometer picks up complex organic molecules that could only be produced by living organisms? What if we find life? It would be, without any exaggeration, the single greatest discovery in the entire history of humanity. Because right now, every piece of life we know about has one thing in common: it all came from Earth. One origin, one family tree. If we find life on Europa, even microbial life, even bacteria, that means life didn't just happen on Earth by some incredible cosmic accident. It means life is something the universe does, regularly, across billions of worlds. It means the night sky isn't just full of stars, it's full of life, and that would change everything: philosophy, religion, science, politics. The entire way humans understand their place in the universe, rewritten in a single moment. We are standing at the edge of that moment right now. Here's what we know for certain today. Beneath the frozen surface of Europa, there is an ocean that has existed for billions of years. That ocean has water, it has salt, it has carbon, it likely has hydrothermal vents. And right now, a spacecraft the size of a small house is hurtling through deep space at over 100 kilometers per hour, heading straight for it. In 2030, Europa Clipper will arrive, and the data it sends back could answer a question that humans have asked since the very first night someone looked up at the stars and wondered, are we alone? We built the telescope that found the carbon. We launched the spacecraft that will investigate the ocean. We are the species that asked the question, and very soon, we might finally get the answer. Stay curious, stay watching the sky.